In the next few experiments, we'll be dealing with the science of motion. Different types of motion have always intrigued the human mind for centuries. The movement of air, the movement of water, the movement of heavenly bodies, the flight of birds. And human mind and human understanding has been searching for the common ground in all these motions. For centuries, human understanding was primarily based on two things: observation and speculation. That is, forming of a hypothesis. It was sometimes in the 16th century, it is said that it was the Italian scientist Galileo who introduced two more dimensions to this human understanding. And that were experimentation and demonstration. And that was the beginning of the modern science based on four legs, that is, observation, speculation or making of hypotheses, experimentations to test those hypotheses, and to demonstrate them to a larger audience and public. For understanding or dealing with science of motion, there is a very simple instrument which very beautifully demonstrates various aspects and various laws of motion, and that is the simple pendulum. It is a small metallic bob hanging or swinging at the end of a thin string. This instrument was used by Galileo for umpteen number of things and demonstrations, including the field of medical science as a pulsometer. Now, if you look at a simple pendulum, it is in its simplest form, it's highly trivial and uninspiring, especially to a young mind. But for a child, every child rather, who knows the fun of being on a swing, either alone or in a group. So in the next experiment, I'll be using a swing to demonstrate certain aspects of motion and certain laws of motion. Take a small glass, preferably of plastic, because it will avoid the danger of getting shattered while doing the experiment. Fill it with water up to the brim. You find that it's very difficult to hold the water without spilling. The slightest shake of the hand makes the water fall. But instead of keeping it on your hand, if you place it in a swing, and place it gently on the center of the swing, hold it and slowly start swinging it and build up the swing. You can swing the glass up to 90 degrees. The glass becomes horizontal, but not a drop of water falls. What could be the reason? The same glass, the same swing, can even do another experiment. Swing it slowly, then build up the swing, and you can take it in a small circle. Yet, no water falls. The glass remains to the brim. What could be the reasons? What are the forces which are holding back the water from falling from the glass? It's one of the it was one of those questions which was first asked by the famous scientist Galileo while dealing with gravity. In the experiment, you saw that the glass full of water swinging on the swing, even when it became nearly horizontal, the water did not spill or fall down. It appears that the water was defying gravity. But if you observe closely, it is entirely different. As the swing reaches the end, the glass becomes horizontal, the water starts falling. But as the water is falling, the glass also starts falling, and the swing also along with it. As the three are falling together, and according to Galileo, the gravitational acceleration due to gravity, is equal on everything, big or small, heavy or light, solid or liquid. Hence, they remain together. On the other experiment, you saw the same water in the glass virtually being swung right overhead and coming back again. Galileo did not have any explanation for it. It took nearly 100 years for Newton to explain this phenomena with action and reaction, with centripetal and centrifugal forces in play. And it's clear that while technologies may advance rapidly, scientific understanding is slow to come. Thank you very much.